Hey Geometry, welcome to the last section from probability. So this is two-way tables. Two-way tables are actually one of my favorite ways. They're a lot like Venn diagrams, truthfully, but there's just a little bit more information you can get into them. So a two-way table is a table that records the data that pertains to two different categories. Thus the two-way table, two different categories. The two-way table below shows the results from a survey in which students were asked their gender, male or female, so that's one category, and their dominant writing hand, left or right-handed. So two sets of categorical data there that we're dividing up, and that's what a two-way table does. You'll always have like kind of a row variable and a column variable. Joint, and then that's one nice thing so that this has, like if I wanted to know male and left-handed, it's that right there. So that's kind of like the overlap of a Venn diagram. If I think about like a male bubble would be these are the males and then these are the left-handed, and then like that overlap is there, and then these are the people who are not male or left-handed. And you can kind of think about this as being a whole bunch of Venn diagrams, right? So like we could also have female and right-handed, and so there are 86 female and right-handed, and then there's the females here and the right-handed there. But the other thing that this adds is row totals and column totals. So that can be very, very useful. So if we add those up, those add up to 55. 9 plus 86 gives us 95. We could go ahead and figure out the grand total now by adding those up. But we'll also see this the same here. If we go add those up, you get 16. 48 and 86 gives us 134. And if we add these up, we'll get the same thing. So both ways we get 150 individuals in this. So joint frequencies are the individual data entries, so not the totals, but these. So the joint frequency or joint, and you can ultimately turn into a joint probability by doing it over 150, but it's like left-handed and male is 7. Right-handed and male is 48. Female and left-handed is 9, and then female and right-handed is that. And so those are kind of the ands for both of those. And then we have marginal frequencies, and so those are these totals. So like the total number of men is 55. The total number of women is 95. The total number of left-handed is 16, and the total number of right-handed is 134. So, upon exiting, passengers on a plane were asked if this was their final destination and if they checked any bags. The results are shown in the table below. Complete the table by filling in the missing joint and marginal frequencies. So it's kind of like a little puzzle here. You can fill in what you got. So we know that this total has to be 136. So if we subtract the 50, we get 86 there. We also could have gone this way. Then we can get this total by adding across that row. 16 plus 48 gives us 64. Now we could add up to get that total. So if we do that, 136 plus 64 is 200. And then we can do 200 minus 134 to get that, or we could have added these 50 plus 16 to get 66 for that total there. And so we can fill each of those values in. All right, so then relative frequencies, these are basically percents, and they kind of equate to probabilities as well. Joint relative frequencies, the values in each category divided by total. And then marginal relative frequencies is the sum of the joint relative frequencies in each row and column. So they want us to give us basically these as percentages is what was going on here. So give the joint and marginal relative frequencies using the data in example number 2. So going back up here, we were kind of just turning these into percents or proportions. So 50 out of 200. So this first one would be like 50 out of 200, and that is 0.25. And so that is a joint relative frequency. That's the probability that they are yes checked bags and yes are at their final destination. So that's 25% of individuals. And then we can kind of do the same. 86 out of 200 becomes 0.43. And if we add those up, we get a total of 0.68. And that's 68% of people said yes, they checked bags, right? And so that's that. And this number is actually always just going to be 1. Since we are dividing by our totals. Here, 16 divided by 200 ends up being 0.08 or 8%. The next one, we had 48 divided by 200. So that'll be 0.24, and then we can add those up. We get 0.32, and that makes sense. We could have figured that out before. That adds up to 1. And then we could add up these columns. What proportion of people are at their final destination? 0.25 plus 0.08 gives us 0.33, 33%, about a third. And then if that's 0.33, this is going to be 0.67. That's to add to 1, or we could add those two together and get those relative frequencies, which are kind of the same thing as like proportion, percent. And you can actually use them as probability of a randomly person selected. What's the probability that they're, yes and yes, that they're at their final destination and are checking bags. All right, so continuing on onto the back. Students in band were asked if they rented or owned their instrument and if they practice at home. The results are shown below. If a student is chosen at random, find each probability. So find the probability that they do not practice. So the probability that they do not practice is the total here. So this is where it is nice if we have some totals. So ultimately, if I add these up, 62 plus 28 plus 20 plus 15, you get 125 total. That's the grand total. And then, total. And then if we add these up, 28 plus 15 gives us 43. And so that's 43 out of the 125. So that's the probability that they do not practice, 43 out of 125. And you can do the decimal and percent as well. Practices and rents. So practices and rents is just the 62 out of 125, since it was an and. It's a joint probability there. 62 out of 125. And you can convert that. Does not practice given that they own. So we're just now focused in on the proportion that own. So it's out of those 20 plus 15, out of those 35. What proportion do not practice? So that would be 15 out of those 35, which we can reduce, we'll divide both those by 5 and get 3/7. And then rents, given that they practice, so we're just focusing on our practices. So this is out of the 82 that practice. The proportion that rent is 62 out of those 82. And that one we can reduce to 31 out of 41 and do decimals or percents. Next one, a test was given to 3 classes. The results of the test are shown below. If a student from one of these classes is chosen at random, find each probability. So we've got the different classes and the proportion that passed and did not pass. So those are our 2 different categorical variables, which class they're in and whether they passed or not. And this one's a little bit bigger. So first of all, if we add those totals up, 19 plus 24 plus 21 plus 3 plus 8 plus 5, we get at least a grand total here of 80. So 80 total. And so then ultimately the probability that they're in class B, so that we can add that 24 plus 8 more, gets us to 32 out of 80, and that will reduce quite a bit to 2/5. And we can do 40.4 or 40% as well. In class C or passed. So this is a little bit different. In class C, so we want these individuals, I'm going to draw on here a little bit. In class C or passed means I want basically anything that got circled in either of those. So I want these folks, these folks, these folks, and these folks. So, and this is one where we could do this thing where we could add up all of our individuals that passed and all of our individuals that are in class C, but we would add the 21 twice. So be careful about that, the double counting of those that are in class C and passed. But we could also just add up these 4 numbers. 19 plus 24 plus 21 plus 5 gives us 69. It probably is actually easier just to add up the 11 that aren't in those circles, and it's out of the 80 overall. So 69 over 80, and you can find the decimal or the percent. All right, let me get rid of those. The next probability is we want to know the probability that they did not pass given that they are in class A. So given that they're in class A, so out of those 19 plus 3, 22, what's the probability that they did not pass? So there were 3 out of the 22 in that class that did not pass. And then in class B, given that they passed, so we're just focused here on these individuals that passed. So if we add those up, 19 plus 24 plus 21, we get 64. So it's out of the 64 that passed. What's the probability there in class B? And that's 24 out of the 64. And that fraction will reduce to 3/8. All right, next example, a restaurant has chocolate, strawberry, or vanilla ice cream available in a cup or cone. The table to the left gives the choices of the last 200 people who ordered ice cream. Complete the table below with the joint and marginal relative frequencies, then find each probability. So we can do it in terms of the whole numbers. We can also do this in terms of relative frequencies. So if we add all these up, 42 plus 28 plus 18 plus 55 plus 22, and plus 35, we'll get 200, right? So that is the total, right? So that's all the 200 people. So if we divide each of those by 200, we'll get relative frequencies, so or probabilities. So 42 out of 200 is 0.21, 21%. 55 that are cone and chocolate, and it lines up nicely, is 0.275. 28 out of 200 is 0.14, and so on. 0.11, 0.09, and 0.175. And then we can get the total relative frequencies by adding those up. So these two add up to be, so 0.21 plus 0.275 adds up to be 0.485. Strawberry adds up to be 0.25, and then this one is 0.265. This one is 1 always when we're doing relative frequencies. And then these column add up to be 0.44 and 0.56. All right, so this makes things a little easier. The probability that they got a cone is 0.56. The probability that they got cup or chocolate, so cup or chocolate is a little bit tricky. So this is where we could do like 0.44 plus 0.485. Those are a proportion like a cup. Those are a proportion like a chocolate. But we double counted this 21%, so we could do minus 0.21. So that's a trick we could do. Alternatively, we could have gone in here and just added up these three numbers, and that would have done the exact same thing. So if we do that, we end up with 0.715. 715 or 71.5%. Strawberry given cone. So we want strawberry and cone is 0.11. Out of the cone, folks, which is divided by the probability that they got a cone, 0.56, that will give us this probability, and it works out to be 0.1964. So about a 20% chance that they got strawberry given that they got a cone. And then cup given not vanilla. So this one's a little bit weird. So we're talking about our non-vanilla people, which is really, I'm going to circle it up here. It's out of those people. So we can add up those two probabilities together, 0.485 plus 0.25. So that'll give us 0.735. And so then we want to know the probability they got a cup, and that would be these folks, the cups, which we have to add those two together because we're going to combining these two rows, the non-vanilla people. So 0.21 plus 0.14 gives us 0.35 out of 0.735, which works out to be, we'll keep that as decimal, 0.4762. About a 47% chance, 48% chance that they got a cup, given that they did not get vanilla. And there's some conditional probability.